you're currently in the system facing. Thank you. You're currently in the systems facing track. We also have researcher facing track, data facing track, emerging centers, and the strategy and policy track. And they run at a given day during the month, every month. These are some of our working groups in terms of professionalism and mentoring. We also have a student workforce. Oh, there it is right there, the student workforce interest group, HIPAA interest group, and a data storage group. Um, we're sort of organized and we're getting more organized lately in terms of we've named an interim board and we're going to try to make CARC a full scale nonprofit so it can kind of exist on its own going forward. But we also have the chair's leadership team, where each one of those tracks have a leader in them, have two leaders in them. And for instance, Matthew Smith and Brian are our co-leaders in the systems group, but they meet on a monthly basis. We also have people that do logistics, and we're started an engagement group too. And this is a little bit more about what we do. And we ask that if you get involved, you can reach out to your favorite track, see if they need steering committee members. If they don't, you can participate every week, volunteer, fill in the notes, and please, anybody's encouraged to fill fill in the notes during this presentation today. So without further ado, let me introduce you to Brandon Biggs. He's a high performance computing system administrator at the Idaho National Lab. He manages HPC and AI/ML systems, performs scientific computing research, mentors interns, and makes scientific computing as accessible as possible. He's part of a team at INL that focuses on decreasing time to science and enhancing the accessibility of scientific computing. So without further ado, Brandon, why don't you take it away? And like we said, if you can put your questions in the chat or you can raise your hand and we'll try to come up with a reasonable time to interrupt. So I think
Perfect.
you had to steal the screen from me. So go ahead,
Yep.
please,
Yep.
Brandon.
Yeah, thanks, Jim. Sorry, let me share here. Should be screen one, share. I don't know why it keeps changing. Okay, perfect. Yeah, thank you, Jim. Good morning, good evening, good afternoon, everybody. Thanks for having me. Today, I want to talk about some of the insights that I've started to experience while deploying large language models at Idaho National Lab. So my background has historically been in HPC. So, doing a lot more modeling and simulation, FP64. But the last couple of years, as everybody on this call has probably seen, tools like ChatGPT have kind of been the hot topic, right? So what that's done is that has pushed me and then others to start to explore how can we help people utilize that as well as typical HPC systems, right? So what we have done is we've started to look at hosting on-prem models as well as in the cloud models, and I'll talk about both of those a little bit. But to kind of get started, I wanted to give a brief overview in addition to talking about on-prem and in the cloud LLMs. I also wanted to talk about, I'll just give a very brief overview of what they are, kind of how they function. Most of you are probably already familiar with that. Definitely won't go into the weeds on how they function. Just highlight a couple of quick things. After I talk about on-prem and in the cloud, the different ways that you can run them, I'll talk about some of the technical challenges that we've ran into. I'll talk about some solutions that we've kind of come up with that have worked well for us. I will then talk about data privacy, compliance, which are really big for us at a national lab. I'll talk about integration with the LLMs, with other tools, and then also talk about kind of what we're seeing moving forward with LLMs. So super quick, jumping into how does a large language model work? If you get some type of input like the audience found the AI presentation to be blank, what's kind of the next step that's going to occur? A lot of it is looking at the probability of previous training data, right? So you look at other tokens in similar pieces of data that the model was trained on, and it's going to have probabilities of something like, the audience found the AI presentation to be informative 21% of the time based on the model being trained. Exciting was 15, interesting 18, boring 7%, and it keeps going on. What really changed, like kind of natural language processing, NLP, up until 2017 was the paper "All You Need Is Attention" that came out of, I believe, the Google research labs. And that's what really kind of started to change how these models function, and what really kind of started the models that we're seeing today, or even what we started to see in, what was it, late 2022 with like GPT-3, right? So on the right side of the screen here is kind of an example of how this attention layer is functioning. So rather than the model just looking at maybe the couple of previous tokens, it starts to look at emphasis on other tokens. So rather than it focusing on the presentation to be, it may provide that attention to the term audience or the term AI, right? Or it kind of puts it all together. So as many of you already know, what are some of the things that LLMs are being used for? What are their capabilities? Turns out they're pretty good at text generation. Now, whether or not that text that's being generated is useful is kind of pretty dependent on the situation, but that's obviously one of the easiest things for it to do. It's pretty good at language translation, content creation, summarization, information discovery, as tools like deep research have come out. And you combine utilities and capabilities like being able to search the web, we have found that it starts to be pretty good at that search aspect, right? Google has made the AI capability one of their first things that you see when you Google something. Now, as most of you have also probably seen, it's sometimes misleading or just blatantly false, right? So you do still have to be careful to check the citations of where it's pulling the information from, but also be cautious of not just relying on the citations it creates, because a lot of the times those are inaccurate, right? So that's just something you have to look out for. And then the hot topic I'll talk more about later is kind of some of the automation that's coming with AI agents, right? So they're finding that the large language model is a really powerful interface from human text or human speech, right, into something that's actionable from very programmatic tools and applications, right? So rather than AI doing everything, it's just kind of the interface to go from the natural language that a human would say to something that robots can kind of understand a little bit better. Sorry, I was just scrolling up on the chat there. Okay, so let's jump into kind of running large language models on-prem. There are multiple benefits of doing this. Some of them are, enhanced data security, right? Because you're running the models, whether you download them from Hugging Face, you train your own, things like that. Like when they're on-prem, you could pull the networking cable and it would still run, right? You could still generate text. And you can still get results from it. So that is a really kind of exciting opportunity for a lot of organizations that have sensitivities around their data, right? And even if they aren't sensitive, some people are just like to be cautious of who is seeing the data, not just the data that's generated, but also the data that is being fed into and then used in whatever way, right? So that's one of the biggest benefits of on-prem models, is kind of that data security. One of the other things that we've kind of seen is that compliance with regulations. Being part of a national lab, we tend to have a pretty high set of regulations. And because we're a nuclear lab, our regulations are, I would say, are even a couple steps higher than some of the other labs that don't work with nuclear information, right? Whether that's reactors or just the data that we feed into them, right? So there's a lot of regulations, and those of you who deal with regulations or regulators probably know that like things happening, innovation that happens with regulations happens a lot slower than like if you don't have those same regulations, right? The finance industry has a lot of regulations there as well. We've got NRC, for example, quite a few regulations that we have to be very careful of. So being able to run things on-prem really helped us. We're talking almost 2 years before we were able to access any cloud models, we were able to run them on-prem. So that was a big benefit to us as well. There starts to be more customization options, right? They allow for, like, each organization kind of has its own needs when it comes to AI or utilities in general, right? But being able to utilize the on-prem models in a way that best works for you turns out that it can be pretty beneficial from like an operational perspective, right? And then one of the last benefits I want to highlight is that predictable cost. Usually, if you're trying to run it on-prem, you already have the hardware, or you are going to be acquiring the hardware. Maybe you lease the hardware, and you're paying it off over a couple of years. But the hope would be is that you have a predictable cost with how users can use it as much as they want. You will always know that you've already sunk the cost in the hardware. Obviously, if you are kind of renting a cloud host and then running it on there, so you've still got a little more control, the cost isn't as predictable. But I mean, if you've already purchased the hardware and you're running the models on there, you're not then paying for that hardware as well, right? So that predictable cost is a benefit. But there are some challenges with that, right? As all of us who work with hardware understand, like, that infrastructure is absolutely an investment, right? Not only from the actual server GPU's perspective, but you're also talking the facility, the data center, power, cooling, et cetera. Like, there are challenges in that, and it's not cheap, right? GPUs, anybody who's tried to purchase any data center GPUs, I mean, even consumer GPUs, knows that these prices are not cheap, right? You're still talking a potentially significant investment. There are a lot of people who run smaller large language models on, I would say entry-level consumer-grade GPUs. I mean, even the NVIDIA 3090 series and kind of up. But if you start to want to run larger models, it is quite the investment. I mean, you're talking, starting low at 5K, but the bigger the model, usually the more GPU memory you're going to need. So you start to increase that pretty substantially, right? And depending on, what kind of pricing you get, maybe what industry you're in, you could easily start to spend tens of thousands or hundreds of thousands of dollars pretty quickly on hardware. And when you think about it, like, you look at the cost of generating 1 million tokens using OpenAI or Anthropic or Google, whatever, like $100,000 for hardware goes a long ways for generating tokens, right? So the on-prem, like, reasons that you want to run it, regulation, security, privacy, you really have to evaluate those to see if that's something that's worth it, right? And then of course, there's the ongoing maintenance. I can't tell you how many times that the servers that we have on-prem that host this have gone down, or we had a power bump in the data center that crashed everything, and then you start getting emails like, why is it down? So that's just something you have to do, right? You also have to be in charge of updating the servers that they run on, making sure that they're patched, things like that. And then there also are it also requires a little bit of expertise in machine learning. I would say it doesn't require a data scientist. You often don't have to be familiar with TensorFlow, PyTorch, the low-level kinds of things. But there are some challenges of utilizing GPUs and, like, error messages with these inference frameworks that you have to be a little bit familiar with, running out of GPU memory. Okay, how can I fix that? Things like that, right? So there's a little bit there. But tools have made it incredibly accessible to people, even if you don't have a lot of that, like, AI experience. But with that, let's kind of shift to talking about AI models, large language models in the cloud, because there are benefits and disadvantages there as well. So let's talk about some of the advantages of cloud models, right? I love this. I love XKCD, so I wanted to share kind of the XKCD on cloud, right? But there are the advantages. Really are you have flexibility in using different model providers. You have benefits of, like, scaling your capabilities. I mean, if you want to scale on-prem, you're talking about purchasing more GPUs, which can take time, not only from a, like, setting up, like installing perspective, but just in getting them too, right? It could take months if GPUs aren't available, or even longer, depending on what you're going for. So like, unless you're a hyperscaler who can throw absurd amounts of money at this, like it is really hard sometimes to scale up. And there are some cost reductions too, depending on how many tokens you're planning on generating, right? If you are just wanting to play with something and you don't have hardware and you don't have those data sensitivities, I would absolutely recommend using cloud models, right? Anthropic, OpenAI, et cetera, they're very cheap, like surprisingly cheap at times, depending on the amount of tokens that you want to generate, right? The other thing is that the cloud models are often proprietary to some extent, and they're pretty good. I do have a slide coming up in just a minute where we'll kind of look at how cloud models compare to on-prem models. But if you want the best of the best models, they are still in the cloud. So those are just some of the things that you kind of have to weigh when you're looking at, should I just push everything into the cloud, using a cloud API versus, trying to host some things on-prem. So let's talk about some of the, the industry AI benchmarks. And I want to caveat this with, benchmarks aren't everything. Anybody who's kind of, been watching benchmarks of large language models develop over the last couple of years has seen like, oh, this new exciting model came out. It scores incredibly high in benchmarks, but turns out it's really not very good at normal day-to-day tasks, right? So that's kind of the caveat, is that these benchmarks can be gamed, right? So they aren't everything, but they're at least something to start looking at that isn't totally anecdotal, right? So we've got a couple of benchmarks I wanted to compare here. The first is one called AIM. It's competitive math, no tools, GPT-5 Pro, which was just announced, I want to say within the last 3 weeks, is scoring the highest. And that's not really a surprise when you look at some of how a lot of the models are developed, right? Each of the main AI model providers, Google, Anthropic, Claude, Grok, for XAI, they often kind of beat the rest of the models when they release a new one for a small amount of time. I mean, unless you're Llama 4 and you score really good on the benchmarks because they're gamed a little bit and it's not very good for everything else. Really, when the big AI providers release their newest models for a small amount of time, they usually are the best. And then even then, for some time, the models will excel at certain things. For example, Claude from Anthropic is very good at coding generally. But that kind of moves me into the next benchmark that we look at is the software engineering benchmark. GPT-5 Pro again scored the highest, but Claude Opus, which is the kind of the flagship model from Anthropic, is not very far behind, right? Even though it is several months older. So, but if you look at GPT-4.1, Gemini 2.5, or even the open source models, which are the last 4 columns, you start to see that the cloud models really outperform, but there's really not a huge difference. If you look at the fourth to last column, the GPT OSS column, you see that this is a model that OpenAI released so that you can download this, run this on your own hardware. At its size, it does require a significant amount of hardware, or at least a pretty good GPU. But you are getting decently close for something that you can download, run locally, and you can control the full flow of information, right? GPQA Diamond is graduate level science questions. The reasoning models, which are indicated by the little caret on some of these. I guess the only non-reasoning model here is really GPT-4.1, but the reasoning models really started to push that next level of progress in a lot of these benchmarks, because it requires more than just like immediately spitting out an answer. They need to be reasoned with, right? And that's what some of these benchmarks try to capture is that when you have these types of questions, whether they're math questions or science questions, it's not just something that can immediately be solved. You do have to kind of reason through them, right? Hence why they're called reasoning models. but then, I do show a couple more open source models. Everything after Gemini 2.5 Pro are open source models that can be run locally, right? And a lot of these scores are pretty comparable within a couple of percentage points, right? So that's just something to consider, as well as, like I said, the best of the best is still going to be using the cloud providers models, but open source models are pretty dang close, which is really exciting. But there are also some challenges as well, right? If you're using cloud models, it's not always the best for privacy concern reasons, security risks, and definitely regulatory compliance, right? Especially on the government side, there are a lot of people who have to sign off on us being able to use cloud models. If the vendor if the company providing the model or the access to the models, it does not have certain checks in place and certain like assurances, especially for like HIPAA data, other types of CUI data, controlled unclassified information, FERPA, all sorts of things like that are things that, like, these cloud models are trying to move very quickly, but they aren't always checking all of the boxes and working with the regulators to have those environments ready for people with privacy and security concerns, right? So those are some of the other things. Like I said, we would not have had access to any large language models up until like 8 months ago, unless we were running them on-prem, right? So that was a big balance for us. The cloud companies, OpenAI and Anthropic, I think is the furthest along in having a lot of those more secured or sensitive environments, right? I'm still not talking classified, but even FERPA, or at least the assurances or the agreements in place that say they won't train on your data. So just some other things to kind of keep in mind there. For a lot of purposes, they work great, but some folks have sensitivities on their data. There are also some cost and scalability considerations, right? So if you have a lot of people trying to do a lot of things, then like it's easiest to scale with cloud. I mean, I think we all know this when it comes to computing as well, right? A lot of us are pretty limited on-prem or just with our budgets in terms of buying more hardware, right? So sometimes you have to kind of burst into the cloud for things. But you also have to consider like cost management, right? If you are an organization, say you're a university with a bunch of colleges underneath, right? You may have to implement some type of cost recovery, right? Because one group may use it substantially more than another, and I'm sure that those groups do not want to pay the same when they're not using it the same, right? So that's something else you have to consider. Obviously, you may have to do that on-prem as well, but you may be able to kind of loop that in with your current cost recovery or kind of how you are having people pay for the current compute that you may be offering them. And you also have to look out for like unexpected expenses, especially with the rise of agents. I mean, you're talking about potentially generating or inputting millions of tokens in a very small amount of time. And that starts to add up pretty quickly, especially if you're using utilities like Claude Code or OpenAI Codex that are helping you plan whatever it is that you're working on, whether it's a programming project or, I mean, even documents, papers, forms, things like that. They do a lot of reasoning behind the scenes, which generates a lot of tokens. So that is something you have to watch out for. It can still be cheap, but at the same time, you could also, oh, whoops, I accidentally hit enter on that and left for the day, and now I have $100 in tokens that I spent, which, $100 may not be a lot, or it may be, all of your token budget because, you were looking at 50 million tokens and turns out you generated 50 million worth of tokens that aren't that beneficial. So just something to look out for there. So with either solution, though, either way you go, there are other technical challenges and hopefully solutions to a lot of those, right? So, let's talk about like some of the on-prem challenges that you might run into, but also some of the solutions that may work. If you just do decide to run them on-prem, I already mentioned there are significant computational resources required, right? You will need some hardware for this. You can run it on CPUs, you can run it on older hardware. It really comes down to that inference speed and the throughput that you want. If people are okay with hitting enter and they're sending off their inputs and they're okay with it taking a bit before they get an output, that's great. But utilities like ChatGPT, like Claude on the web have really pushed people to wanting responses quickly, which I think is fair a lot of the times, right? Especially when you're kind of exploring. And I mean, everybody wants their science to be performed quicker when they run it on HPC, right? So I would argue that this is really not a lot different when it comes to getting those results. So, that is just something to consider. If you have hardware, it will likely, you'll be able to run some type of model. There's that trade-off, right, with inference speed and throughput. And the number of users with throughput, maybe you can only have one user at a time, or maybe you bought, a AMD or an AMD MI 250 or a NVIDIA A100, H100. You can start pushing a lot more people through. And then you also have to kind of be proactive about hardware management. You want to watch out for failures, uptime. That's important to everybody, right? You want to ensure that uptime because there's a lot of people who may depend on this, just like they do our HPC compute. So something to consider there as well. I'm going to go back for just a sec. The other thing that can be done to improve a lot of the performance is model distillation, which is taking a model that may have been trained at FP16, for example, and reducing that to maybe FP8, FP4 to require less GPU memory, so you have more to produce quicker results or allow for more users. One of the big things that I think will benefit people, especially in the HPC AI community, is with large language models being released open source, there has been a lot of work done to push hardware even further, but also get models, scale them down while they do perform a little less, they perform a little worse to fit them in current hardware, which I think is really great for those of us who cannot afford to always buy the greatest hardware, right? I mean, we're still, personally, we're still running on V100s, A100s. We're looking at purchasing some more hardware, but like many people, we are budget constrained. So all of the efforts being done to allow AI models to run on older hardware, smaller hardware is really beneficial, I think, to everybody, unless you're a big cloud provider and have billions of dollars. Right? But another thing that a lot of people have started to kind of look at, but haven't maybe fully dug into, is the power constraints. As many of us who have kind of paid attention to the news or seen with AI data centers, but just GPUs in general, they are not requiring less power, right? That power requirements are not going down by any means. If anything, it's going up substantially quicker than I think any of us could have predicted, or most of us could have predicted. I mean, you're starting to push multiple kilowatt GPUs, which coming from the V100s being a couple hundred watts to, I think our A100s are still a couple hundred, maybe pushing 300 or 400, to H100s pushing 600, to the next generation talking 1.2 kilowatts per GPU. I mean, you're talking servers that are, if they're air cooled, maybe 8 or 10U, but consuming 10 plus kilowatts in a 10U box, right? And a lot of us may have planned our entire racks to only have 15, 20 kilowatts of power, right? And that's a big challenge that I think everybody is kind of running into. Anybody in the GPU space, right? Anybody who's talking about buying really any generation of GPU within the last 2 generations. And I think it's only growing. So I really wanted to share this slide because while I think the smaller organizations, us included here, are running into power challenges, the cloud providers, the hyperscalers are obviously running into this at a different scale than a lot of us. But I mean, they're talking about hundreds of millions or billions of dollars in investments in ways to get them more power. So being from Idaho National Lab, being kind of the nuclear lab, I always want to put a plug out for nuclear energy and just show that the cloud providers are also investing in this because they need that power in different ways, right? Amazon is focusing with X Energy, spending $500 million. Meta signed an agreement or is working with Constellation, which is another nuclear energy company, to get 1.1 gigawatts of power, right? You're talking huge amounts of power for these GPU systems that they're acquiring. I mean, you look at XAI in Tennessee, right? Their solution was to just get diesel generators and keep pumping in power from these generators. And there needs to be something more sustainable, right? Whether that's nuclear or wind, solar. I'm gonna, like I said, put the plug out for nuclear. That's being worked on, but the power constraints are very real. Again, most of us are working at a much smaller scale, but I mean, even in our own small data centers, 1 or 2 servers may consume the entire power of your rack, right? So just something to consider. One of the other things, very much shifting gears, is what are some ways that people can stay up to date with models, open source software? Because one of the things that people who maybe aren't as familiar with this have seen is that the models are only one part of the problem, right? You could have maybe OpenAI gave you the best model out there, right? They gave you GPT-5 Pro and it could fit on your hardware, but you also need kind of the software and tooling around it, right? So that's another big part of this that I wanted to really point out. We do have some really good conversations in the chat. Yeah, thank you. David said, was talking about the Texas, should I go scroll up? The Texas energy crisis a few years back. Yeah, absolutely. Diesel fuel is pretty reliable, but is it diesel generators and fuel, but is it sustainable in terms of huge data centers, right? And I honestly, I don't think so, even close, right? And like Jim pointed out, that Microsoft plans to reopen the recently shut down 3 Mile Island. Yeah, absolutely. And David, again, good point on tech companies running plants. Is very interesting, right? Rather than a dedicated company kind of producing energy and tech companies buying that, the tech companies are like, well, it'll be cheaper for us and we need more power, so let's just build our own, right? It's really, the next couple of years, I think, will be really interesting and sometimes kind of scary in that. But okay, so what are some of the ways to kind of staying up to date? Hugging Face is an incredible tool. That's the icon is here. I forgot to put the name of it, but hopefully people will recognize that that's the Hugging Face model. Just go to Hugging Face and there are thousands, tens of thousands, if not maybe hundreds of thousands of models, data sets. I mean, fine tunes of models, like Brad mentioned in the chat, are being hosted there. There are other places you can get these models, but Hugging Face has been a very incredible resource for the open source community and the small groups of people who want to get their models out there, right? And it's not just for large language models either. Some people are very opposed to large language models, but Hugging Face is not just about them. I think it really blew up with LLMs, but there's a lot of other models there as well that really incredible. And because of the accessibility, I mean, models and fine tunes of models are releasing almost daily. It's really crazy how it's hard to keep up with it, right? Benchmarks are being created, but also beaten very frequently. Like my slide a couple slides back on the benchmarks. I mean, I took some of the bigger models, but I mean, all the time you're seeing more and more models coming out, and this model will blow up the benchmarks and make the LLM news, but it may not actually be that good, right? It's just overwhelming at times. And something that I've learned that has benefited us was finding a model that worked well for us and then just kind of sticking to it for a little bit, right? If you're always chasing the best models, unless that's your job, you are kind of just always, you're always going to be running into something that might be a little bit better. And you kind of have to balance that a little bit, right? So for a long time, we stuck with one model, and then enough change had happened that we decided to move. But I mean, we're we're usually several months in between our model releases, and sometimes users aren't the happiest about that because they hear about some news about some new great model. It's like, well, we're trying to do our best here, right? So let's talk a little more about data privacy and compliance. There are some ways to work with data privacy, even with cloud models. There's data anonymization techniques to protect that sensitive information. Maybe you want to remove PII, but oftentimes you're also still relying on, if you're relying on AI, you can't be 100% certain that all of the data you want to anonymize is being done, right? So whether that's working, proofreading it or going through by hand, even then you might still miss some, but there's still ways to really reduce a lot of that. You may also implement access controls on specific sensitive data, especially if you're running on-prem. Maybe you've got a model that has access, is using retrieval augmented generation RAG on sensitive data, so you've got to be careful there. But you do kind of have that balance of user privacy and sensitive information that you got to look at, that I keep talking about, right? And again, I wanted to emphasize the regulatory part. There are significant regulatory hurdles. Companies, but also other organizations have to kind of develop a compliance strategy for a lot of this, right? Because ultimately, it doesn't matter. You also have to depend on the users too, right? Because it doesn't matter how good your compliance strategy at an organizational level is. If your user is still putting PII, FERPA, HIPAA, et cetera, into the model, that's still an issue, right? And all of us see this with cybersecurity, right? If it doesn't matter how good your phishing training is, users are ultimately still the ones they're vulnerable, right? Somebody could still fall for that fish, and you could still get a ransomware attack, for example, right? So there's all sorts of things that you still have to be very cautious, and you have to work and train people, right? And that's really one of the biggest things that we've found is that, yeah, great, all of our legal boxes are checked, but we still have to make sure that users understand that there is a limited amount of data that can be used in different areas. So something else to keep in mind. We have started and been improving our best practices for data management. We do regular audits of the data inputs that are occurring, what people want to add to this. People are always saying, oh, I want it to be able to search my OneDrive or my Dropbox, my Google Drive. And you have to be careful of that, right? Because of the potential information that's in there. We also have to recognize that this field is changing very quickly. So we have to be flexible with regulations and data protection strategies, but also know that look, if we're doing research or trying to push the boundaries of what currently is out there, we do need to somewhat be flexible at times, right? Ultimately, we still have to be careful of protecting, especially user information. We want to keep that trust and reliability that we're doing the right things. Some data really doesn't matter that it's out there, but other data is very important, and we have to be very careful with that. So one of the last things I really wanted to highlight was the integration with tools and systems. So LLMs are great for a subset of things, but the power really comes from when you start to integrate them with other things. If any of you have played with Copilot that's integrated with Outlook and your OneDrive, it's really great at searching, at kind of pulling in and summarizing conversations. But it's not the model that's excelling at that. It's all of the tools that exist with it, right? And I think that this is something that a lot of people who are kind of new to this area, or maybe just use the tools at a high level, don't realize is that you have to invest in the tooling around them as well, right? The LLM isn't going to solve all of your problems. Doesn't matter if you get the best in the cloud, the best on-prem, it is still limited in what it has access to unless you build the tools to support it. So that's just a big caveat that I try to add to people to hopefully have them consider. So let's talk about some of the successful integration strategies that we have seen. I think the biggest one was really a phased integration. We have different sets of users. Some of them we may call power users or heavy AI users. Some of them are developers who are familiar with it, but they have their own thing, or they're still a little bit skeptical on AI, right? So maybe they're a different phase. And then we have the people who just want the GUI, the web app. They're in a different phase. So that's something we have to kind of consider, is like rolling it out to everybody all at once is going to be overwhelming on your technical staff who are supporting it, but also on users as well, who are, they may not be educated in it yet. They may need to know, back to your regulations on, what are the rules for this? So, phased integration really has worked well for us. There's also stakeholder involvement, that, you have to include different people to make sure that you have the right people talking, the right tools being used. If you roll out Google Drive, some Google application with Google Drive, but your organization doesn't use Google Drive most of the time, they use Dropbox or OneDrive, like, you just missed out on a big opportunity potentially, right? And I mean, that's a very obvious example. Probably wouldn't happen, but if you don't involve your stakeholders, or don't maybe know who has what needs, you may miss out on that. And then the last thing that I've kind of emphasized a couple times is just the training and support, right? You want to make sure that people know how to use the tools, but also how to use them safely, or at least within your policies, right? So the last thing I want to talk about, was the future trends, especially around surrounding tool integration, because I think that is really what is going to excel the adoption, but also push the boundaries of what these models can do. So there are you kind of have to look at the integration strategies, like I've talked about, integrating the models with your current applications or your current workflows. And the nice thing is that it isn't always AI that's doing it, right? Very simple example is if you wanted to balance your budget, or to look at, you're writing some checks, or you're buying some things, you want to see how much money you have left, you can still use a calculator with the AI. You don't have to hope that the AI will do all of your calculations correctly, because it can still use Excel or a calculator. And it just, is kind of the interface between those things. So that's just something to consider. And there's also the user experience aspect as well, right? You give somebody who just wants to use ChatGPT on the web, give them access to the API, that's not going to do anything for them. But they may benefit if a tool behind the scenes can use the API to then help them with some problem, right? So that's just something else that is quickly evolving, but it's something to consider as well. And then there's also a lot of chances for collaboration. I think that tooling has really blown up. I mean, you look at specific open source inference frameworks, for example. There's a really great one that I use called VLLM. I didn't talk too much about that, but whenever they release, they have frequent releases, because this area is moving very quickly. There are a lot of people who are brand new on each release because they found a bug, or they want a new model being supported. I mean, I think that there is a big opportunity for communication and teamwork to be fostered a little bit. But then you can also use the tools to maybe simplify or explain your question in better detail, things like that, right? So I think there's a big options there, using the models for tools. And then the last thing is really, another XKCD, of course. But the future of LLMs, I think we're stagnating a little bit until the next thing comes out. I don't have a chart of it, but if you look at the performance of models, pre-reasoning models, they were also stagnating a little bit. And then when people figured out that you can train models to reason a little bit better, that the performance of models really jumped up. So that's something that, until we get that next reasoning, whatever that may be, we're kind of plateauing just a little bit. There's training techniques are improving, but there's just multiple things like that. So to conclude, there's a lot of benefit that I think can come from it, but a lot to consider as well when rolling this out to people. Ethical implications, the challenges, but also weighing that against the potential of them. So thank you.
Great, Brandon. Thank you very much. That was terrific and thorough. So I don't think we saw a lot of questions in the chat, but we do have about 5 minutes more for questions if anybody wants to unmute your mic, raise your hand, unmute your mic, and ask a question or put it in the chat. But that was terrific, very thorough.
Thanks.
Scott Bellinger, you had your hand up. Did you have a question?
No, it was inadvertent.
Okay, no problem. Andrew, it looks like you were going to say something.
Yes, yes, I was about to put my hand up. So you mentioned that there's so many models offered, it's hard to manage. And my question is, why can't the users just download the models themselves, whatever they wanted to use? Now, let me just put a little more context. Um, when I was uh, started thinking about implementing LLM service, I was thinking of a standalone nodes besides the HPC. And then what I discovered it was that it was very easy to just have for the users to submit a job submission script, and it run on the GPU node. So they can have the server. Olama is what I'm using. Olama server up for 2 4 hours. They teach their class. The job the LSF the scheduler job ends and it kills the service at the same time, and I don't have to manage it.
Yep.
So that's the context of my question.
Yeah, no, and that's a great point, right? What we do on-prem is we do kind of two things. The first one is that we do allow people to submit to our HPC and run their own models. We don't use Olama. We provide a bunch of documentation for some other tools that are a little more performant, but they aren't as convenient as Olama. So in that case, people can download whatever model they want and try running that. The other thing that we do is we have some nodes set to the side, like you mentioned, where we provide inference for kind of our suggested models. We provide, like we tell them, look, this is available. You don't have to submit the job if you don't want to. Now, what that does for us is that having those two options is that allows for the power users, the people who are okay getting their hands a little dirty, getting in there and testing models, running new models, finding what works best for them. But it also allows our, I will say, less hands-on users to still utilize on-prem models without having to submit jobs, right? We have such a wide range of users that, you tell somebody, maybe they're using Open on Demand to submit a job and they want to spin up Olama with that, right? Great, you can automate that a little bit, but maybe they run into a problem, and then that's more load on your technical staff, for example, right? You maybe get more tickets, right? So it is a balancing act. You are absolutely right that users can do that, and tools like Olama are amazing for helping with that. But we just try to hit both groups if we can, right? The people who don't want to submit the job and the people who do. So does that kind of help a little bit?
Thanks, Brandon. Anybody else?
Looks like we got a question from Wim. I hope I didn't say your name wrong. At INL, do you use RAGs fine-tuning or fine-tuning? If you use fine-tuning, can you elaborate on an example on which layers you retrain?
Yep. Great question. So RAGs, for those RAGs who aren't familiar, that's retrieval augmented generation. And what that is that is not altering the model at any way, but at prompting time, you provide relevant information to your prompt to help the large language model kind of have that context, right? So for example, just a super quick one is when you ask ChatGPT or Claude, whatever, you say, what's the weather like today? Without giving it any context, the model is not trained live. It has no context of what the weather is like today. But using RAG, you can provide it that kind of information at execute time, basically. So to actually answer your question, we use both. Primarily, we focus on RAG. The reason being is, we can fine-tune models, but by the time we fine-tune models, the next, all of the models that have come out are kind of already beating the performance of the fine-tuned models that we have. So unless we have a very specific use case, which we have ran into, where the newest models aren't being trained on, say, some specific nuclear data. Just give you an example because of where we're at. The next generation of models is already coming out and beating even our fine-tuned models, right? So we have found that most of the time it is not worth the compute time or the time to go through and specifically collect and clean up all of your data. It's just not worth it when the next model that comes out is just going to beat everything you did, right? So, and fine tuning, depending on the size of the model, can be expensive. It can be cheap using tools like Unsloth, things like that. When it comes to the layers, it's really just usually the last couple. LoRa's are very easy to use to fine tune. I won't get too much into that. I'll let people Google LORA if they want to for LLMs, but things like that. Hopefully, Wim, that helps answer your questions. Kurt had another one on comparing on-prem versus hosted service. Convert the on-prem hardware to benchmark tokens per second for a given model. Vendors are often yeah, good question. For us, everything that we have seen is that it is, at least at our level of the amount of tokens that we're trying to generate, it is always going to be cheaper for us to use hosted services. That may sound crazy, but like just at the scale that we're trying to do, it's harder for us to justify spending $40,000, $80,000, $100,000 on a GPU or a GPU server, right? When we could just invest that in hosted services. Now, what you can't put as a price tag on there is the kind of the sensitivity of the data that you're processing, right? And that's really for us where we do use on-prem hardware is for the projects or just people in general who have those data sensitivities or we aren't past the regulators yet, if that kind of makes sense. So, but I think it's almost always cheaper to go on hosted, as much as I hate it or dislike it. I don't hate it.
Tim has his hand up. Tim, could you
thank you.
Yeah.
Going back to the question about running models on-prem in jobs versus dedicated service. Could you talk a little bit about, because it seems like if you have 5 or 6 researchers running OLAMA jobs, they're using up cycles that other more specific things could be used for, and a centralized service would just make more sense from an economy of scale kind of thing. So could you talk a little bit about that?
Yep. You're absolutely right. And that's something that we have ran into as well. The last thing we have wanted, but we have seen, is for people to start a job and submit OLAMA or whatever it is and be utilizing the GPU memory, but then go home for the day, or it just sits there, right? That's a big problem that we have ran into. So we have tried to be cautious of what sizes of models people are running, but also the time that they can submit it. And it has worked out pretty well for us in that most people are happier just utilizing the centralized API that they can just use, right? They don't have to worry about setting it up or forgetting it. They can just utilize what we're giving to them, right? So there definitely is a trade-off, but we at least have had good luck on not that many people want to submit their own, if that kind of helps, Tim.
It does. It would seem more natural to me that people would want to use centralized, except for those outliers that want their very special model that, it would make sense to offer centrally. So thank you for that.
Yep, absolutely. Wim had another good question. What kind of jobs work is agentic AI most common? We've got a lot of modeling and simulation codes, right? That's historically what our HPC has supported. We support lots of things, but the modeling and simulations of reactors, things like that. So what some people are researching is how can we utilize those tried and true simulation utilities? How can we utilize those with like maybe an AI front end? So, if somebody says, hey, I want to simulate heat transfer on a pipe or on a material, whatever, we are utilizing kind of agents to help decipher what utility that needs to go to. So, maybe that needs to use code A, but a user may historically have thought that code B did that, but we can use the agent approach to kind of help parse that out. That's on the science side. There's a lot more use cases on the business side that kind of apply to everybody with, parsing different data types or different databases, things like that. So We're still pretty new on the agentic AI in the scientific space, but I think that it kind of seems like everybody's just kind of approaching that. And at least the hosted services or the cloud providers, they care more about where the money seems to be ish on the business side, right? Because not everybody like us, we're HPC science, like we're trying to solve the hard problems there. But I think that the majority of people are probably on the businessy side, which is important too, right? But so
That's great. Thank you very much. I think we'll have to close it off there. We're at the top of the hour. Don't forget next month, it's on the 16th, and the University of Buffalo is moving to multiple data centers, or their alternate title is Changing the Tires on a Moving Car. And that should be a pretty good talk next week. So we'll see you next month. We'll see you next time.
thanks all.
Thank you, Brandon.
Thanks, Brandon.